I welcome you all in 10th session of your Physics Paper 1 syllabus. In our last session, we have seen the classification scheme of musical instruments. Also, we have seen the working of a string instrument sitar. We have studied how a sound will be produced from a string instrument sitar. In this session, we are going to cover the structure and acoustic of few of the wind instruments like flute, clarinet, and harmonium. So, let us start. Let us start with a flute, a very well known common instrument that many of you have been played. So, a flute is a wind instrument which is just like an open pipe. So, what are the different parts of a flute? A flute is divided into three parts. It consists of so-called head joint, its body, we called it as the middle joint, and the end part we called it as the foot joint. So this is nothing but a cylinder which is filled up by an air. So in the head joint there is a hole through which a flute player blow some air inside this main body of the fluid. This hole has a particular name. We call it as the embouchure hole. It is not just like a circle, but it has a specific structure. Along with this embouchure hole, there are many holes in a fluid. There are many holes. The opening or closing of this hole is controlled by the player. While playing a flute, a player can either open or close any of these holes as per the requirement. In this head joint, apart from this embouchure hole, there is something we called it as a cork at this place. This is just like some rubber stopper that you have seen in your chemistry lab at the opening of some acid bottle. So it is just like, you can say, a reflector plate. It is present in this head joint along with this embouchure hole, just in opposite side as that of the middle joint of the fluid. So how a fluid works, how sound will be produced in a fluid, let us see. So basically what happened is that a fluid player blow up some air inside the fluid through this embouchure hole. Now the movement of lip of the player is quite special one. It is not just like when you blow up the balloon, the structure of lip is something different. But when a player starts blowing air in a fluid, there is a particular structure of that lip, and that lip movement is such that the player will blow up air not directly into this air column inside this fluid, but it blow up air at this particular edge of fluid, of edge of this embouchure hole, at like this. Here I have given some example. Suppose a player leaves are here like this. It blows air not directly into the bore or the cylindrical part of the fluid, but it pours the air on the edge of this embouchure hole. Now, as air arrive at this embouchure hole, few part of air enters into the fluid body and few part get outside as shown in this place. But the air that entered into this fluid is of spiraling nature or swirling nature, you can say. So, when a player blows some air inside the fluid in this way, the packets of forceful air enters into the body of this fluid. You can see these are the pressure packets, like you can say it as the pressure packets. So, now what we have to consider? There are some pressure compressions and rarefactions are there that are going to travel through the cylindrical body of the fluid. Now, as these pressure packets travel through this cylindrical body of the fluid, and as we have said that a fluid is an air column, it's just like an air column which is open at both ends. Okay, fluid is nothing but an air column which is open at both ends. So, at both of the ends, the air is just free to move or to perform its maximum displacement. So that at these points, we can say antinodes are formed, that is the points where maximum displacement is possible. But at these points, the pressure on the sound wave is just least. The pressure is just minimum. So we can say this is the pressure node. Pressure node. Whereas when we consider displacement, for displacement, this open part will act as an antinode. That is, the maximum displacement would take place in the open end, at the open end of this cylindrical pipe. Whereas when we consider the displacement node, that is the zero displacement is there. So this displacement node is actually the pressure antinode, where the pressure is maximum at the max of its value. We called it as the pressure node or displacement pressure antinode or displacement node. Sorry, this is a displacement node. So, whenever air enters into the fluid through an embouchure hole, let us say at this point there is hole, air enters into the fluid body in this way, and thus oscillations will start. How oscillations will start? When these air packets, like suppose high pressure wave, it arrives at the end part of the fluid, what will happen? There is a maximum pressure inside and least pressure or minimum atmospheric pressure outside. That is, there is a pressure change at this boundary. Okay, there is a pressure change at this boundary. Now you can notice that whatever pressure pulse has arrived here, that can even escape from this way. It can escape outside, but things are not like that. Whenever there is a change in pressure, of course, at that point, that sound wave get reflected back. Whenever there is a change in pressure, that means we can say the acoustic impedance has been changed at that point. An acoustic impedance is the term which is proportional to the pressure. And whenever there is a pressure term, whenever there is a pressure change, obviously there is an impedance change also. And whenever there is an impedance change, maybe from higher impedance to lower impedance to higher impedance, whenever there is a impedance change, obviously at that from that point a sound wave get reflected back with a phase change of 180 degree. That means at this point the wave coming to right and wave going to the left towards the armature hole, these two waves are of same type but traveling in exactly opposite direction. There is a phase change of 180 degree between these two waves, and thus the two waves that are same in all sense, frequency, wavelength and all, these two waves when travel in exactly opposite direction, a standing wave will be formed. And we know a standing wave is nothing but the oscillations of air molecules, the oscillations of this air particle at its mean position. Okay, at this mean position. So in this way a standing wave pattern will be formed inside the fluid, and as a result of which oscillations will be formed, and thus we could hear a very pleasant sound from a fluid. Now, depending on how the air is going to be blown up into the fluid, and depending on which of the hole is open and which of the hole is closed, these holes, the opening or closing of holes, will change the length of the air column. And as the length of air column changes, the wavelength get changed, and thus frequency also changes. We have studied earlier that in case of a pipe which is open at both of the ends, all harmonics are present, like F1 is to F2 is to F3 is to F4. This ratio is equals to 1 is to 2 is to 3 is to 4. So we can say all harmonics are present in case of musical instrument that are just like the open air column. So depending on the holes that has been opened or closed by the player, various harmonics will be generated inside this fluid, and we could listen a very pleasant sound. So this is all about how a sound will be produced inside a fluid. Now obviously when the sound passes through this body of the fluid, there is some viscous force, or there will be some frictional force that is experienced by the sound wave at the wall of this fluid. So much of the sound energy get lost due to the friction with the walls. So this is all about the acoustic of fluid, in which the vibrations are set into the air column in the fluid by the air jet, not the normal air. You can say these are the air jet blown up into the tube by the player. Have you seen these jets somewhere else? Like if you remember some cigarette smoke, so that cigarette smoke enters into the atmosphere with some spiraling motion. So you can just imagine that motion as like a air jet. So these are the air jets that start the vibrations inside the air present in the fluid, and these vibrations results into the sound. So in this way, we can say a sound will be generated in a fluid in which all harmonics are present, and because of which the sound coming from this fluid is really very melodious one. So this is all about the working of flute, which is a wind instrument open at both of the ends. Now let us consider the next wind instrument, which is closed at one end but open at another end. That is the clarinet. A clarinet. So what is a clarinet? A clarinet is again a wind instrument, but unlike to that of a flute, this clarinet has a mechanical reed. A mechanical reed. Reed. What is reed? We are going to see. Now, just we have seen a clarinet is an air column with one end closed and one end open. In this clarinet, sound will be produced through vibrations that are set into the reed by the player. The frequency of these reeds vibration and hence the pitch of the sound is controlled by the length of the clarinet tube. As like the flute, here also the frequency of reeds vibrations and hence the frequency of sound is controlled by the open holes that are present throughout the length of the clarinet tube. A player can open or close the appropriate hole to get the appropriate length of the tube and hence to achieve the desired frequency of that music. Now what happened when somebody blows an air to the mouth of this clarinet? This is the structure of clarinet. You can see here. There are various keys which could be closed or which could be closed by the player. These are the actually finger keys. In the head part, there is a mouthpiece and various other features, but the structure of this mouthpiece is very important. If you zoom out the mouthpiece, zoom in the mouthpiece, what you will see? There is some cut to this mouthpiece. It is not just like an open cylinder, but there is some special arrangement at this mouthpiece. Okay, at this particular position of the mouthpiece, a reed will be attached. A wooden strip. This reed is nothing but a wooden strip which is a very thin. It is a thin wooden strip that will be attached here at this mouthpiece. So what will happen? A player will blow up some air to this part of the clarinet. So due to this, the vibrations are set into this reed part, which is nothing but a very thin strip of wood. So these vibrations in reed set the vibrations in the air column that is present in the overall structure of clarinet. So there is a resonance between vibrations of this reed and the vibrations of air column inside the clarinet body. These vibrations thus produce a sound wave. Now how actually the reed works? Now let us suppose this is the mouthpiece of clarinet or any instrument, wind instrument, with one end closed and with a reed actually. So suppose this is the mouthpiece of clarinet and this thin strip is nothing but our reed. It is a reed. Now suppose the player blows some air inside this clarinet like this. So whenever air will blow up inside this body, a high pressure pulse will start moving through this body of clarinet. This high pressure pulse, when it starts towards the open end, at the boundary of this open end, there is some impedance change, as there is a change in pressure at this side and at this side. So as pressure changes, obviously there is a change in impedance at this particular edge. Due to the change in impedance, this high pressure pulse, when arrives at this open end boundary, it gets reflected back with a phase difference of 180 degree. So a high pressure pulse, it becomes a low pressure pulse, which again travels towards the mouthpiece of clarinet. But as this low pressure pulse start traveling towards the mouthpiece of clarinet, a phenomenon like sucking of air takes place here, so which force the reed of the instrument to come closer and closer and closer towards this part. So as this low pressure pulse finally reach at this another end of the clarinet, what will happen? This reed completely get attached with the rest part of the mouthpiece, and thus it forms an almost close end. Okay, this is not actually created close end, but this closed end will be formed by a moving reed. So this reed get completely attached to the rest part of the clarinet, mouthpiece of clarinet, and thus form an almost closed end at the another part of the clarinet. So for this low pressure pulse, this part will act as an almost closed end, from which this low pressure pulse get reflected back. This low pressure pulse get reflected back, but see here there is no any phase change. This low pressure pulse reflect back as a low pressure pulse. So this low pressure pulse, when arrives at the open end, again it converts to a high pressure pulse, and as this high pressure pulse moves towards the mouthpiece of clarinet, this reed which was get closed start opening one, and at particular position of this high pressure pulse, the reed get completely opened, through which clarinet player blow up some air into the clarinet. As a result of these two waves that are same in all sense but different in the phase, when these two waves superimpose to one another, they form a standing wave pattern, which is nothing but the oscillations, or you can say vibrations, and these vibrations results into a sound coming from the clarinet. So as we have already studied, in case of open end, the maximum displacement of particle could take place. So this acts as an anti-node for displacement, whereas node for pressure. The closed end, at the closed end, the points are just fixed. They are not at all free to move. So displacement is 0. So we can say these are the notes. And in this way, various harmonics, higher harmonics, will be created inside the clarinet just by changing the total length of the clarinet tube. How one can change this total length of air column inside the clarinet tube? By changing the position of, not position, but by closing or opening the holes that are present on the clarinet, finger holes. So these finger holes help in changing the length of the vibrating air column, and hence it allows us to change the pitch of the sound. So as we can notice here, not all harmonics are present in clarinet. In flute, we have said that all harmonics present. That is, the ratio of harmonics is 1:2:3:4, is to 5:7, 5:6, and so on. But in clarinet, the ratio of successive harmonics are, this ratio is 1:3:5:7, and so on. So we can say not all harmonics are present in clarinet. So the sound coming from clarinet is not as much melodious as that of the flute sound. So this is all about the working of clarinet, which is an instrument, wind instrument or aerophone, such that its one end is open one and one end is almost closed one. The next wind instrument that we have to study as part of our syllabus is the harmonium, a very well-known instrument for all of us. It is the harmonium. It is supposed to have an Indian origin, but actually it is not. The harmonium is said to be initially used in Europe. So this is the harmonium that you have already seen. You may think that it is just like a piano, as there are some black and white keys, like in piano. But it is not an instrument which falls into the category in which piano falls. The piano is a chordophone, that is a string instrument, whereas harmonium is a wind instrument. It is an aerophone. So, what are the different parts of harmonium that you can notice here? There are some keys. Okay, there is some flipped part here. We called it as the bellows. And you have noticed that a player playing a harmonium moves this position of bellows while singing some song. So these are the bellows. If you remember, or if you have noticed, there are some holes at the opposite side of this bellow. There are some few holes. If you notice, there are some holes to this back side of the harmonium. That holes, we called it as the air valve of harmonium. Handles are also there to carry harmonium from one position to another position. And there are some stoppers, or there are some stops. So this is a structure that we can see. But the main part of the structure of harmonium is below this cover. If you remove this cover, what you will notice that there are some reeds that are present in harmonium. If you remove the cover here, we will see some reeds are there. So a harmonium is nothing but a wind instrument with many reeds. So the formula is that For one key, there should be at least one reed. For one key, there should be at least one reed. For a good quality harmonium, two or three reeds are found to be associated with every single key of the harmonium. For every single key of harmonium, at least one reed should be present. So you can see here the structure of reed. Reed. It is something that should be vibrant. Like we have seen in clarinet. In clarinet, these are the reed vibrations that allows air inside the clarinet to vibrate. So, in case of harmonium also, there are reeds which are nothing but thin metal plates, mainly made up of brass. These are the thinnest metal plates and are arranged in this part of the harmonium. Okay, so where is the air inside the harmonium? So whatever the part you are looking in this space, it is the sound box of harmonium. Sound box of harmonium. So what basically happens when air comes into the harmonium through the air valves present on this side of the bellow? When air comes inside the harmonium, it passes through the bellows. These bellows are nothing but the thin layers of some thermoplastic material. These are the thin layers of some thermoplastic material which are fixed at one end but are free from at another end. So air coming from the air wall pass through the bellows. What is the function of this bellow? The function of this bellow is just the incoming air towards the reeds with a greater pressure. So an air pass through these bellows and comes to the internal bellows. There are some internal bellows also. So this air inside this internal bellow that is present within this chamber that allow these reeds to vibrate. Now, how to decide that which reed should be vibrate? So these are the keys. These keys decide which airway we have to clear and which airway we have to close. So it is decided by these keys, black and white keys. These black and white, below these black and white keys, there are some air blocks that are maintained by these stops, and thus by pressing a particular key, we will decide which vibrating reed has to count to create a sound coming from a harmonium. And thus that particular reed start vibrating, or the vibrations of that particular reed will be used for the sound production. And as a result of which we could hear particular music from the harmonium part. I got a very good image of working of harmonium from a blog. So I thought this is quite nice structure wherein all things have been represented in a very nice way. There are some keys, below keys, there are not below but beside the keys there is some reed board over which the reeds are there. The reeds are arranged there in the set, one set, two set, three set, like this. So under the reed board, there are so called the air holes. There are some air holes which are actually maintained by these stops, stops, and this is something what you call it as the air valve through which air enters into the bellow. This bellow push up that air inside the harmonium body, main body. So which part we want to vibrate, of the which part of the reed we want to vibrate, that will be decided by these keys. And in this way we could hear a very good sound from a harmonium instrument. So as I have said, harmonium consists of the main body, the air valve through which an air enters into the bellows. The bellows are nothing but the airtight cavity that is used to force a strong blast of air into the internal bellow. Into the internal bellow, there are some keys that decide which reed vibrations we have to consider. If we compare the number of keys of harmonium with the number of keys of piano, the keys present in harmonium are lesser in number as compared to a piano key. In general, a piano have 88 keys, or in terms of octave, we can say a piano have 7 or 8 octaves. But in case of harmonium, the number of keys are only 41. So 41 is quite less as compared to 88 number of keys in piano. So harmonium has only 41 keys, which form 3 octaves. So there are some reeds also that are mainly made up of brass. These are said to be the metal tongues of harmonium. These reeds, it is the part that vibrate as air passes over them, and thus with this vibration, an air inside the box resonate with the same frequency as that of the reed, and thus we could hear a sound from the harmonium. These are the rest of the things that we have already discussed in our structure of harmonium. So I hope you got the in general view of how sound would be produced inside the wind instruments like flute, clarinet, and harmonium. I hope you have enjoyed this lecture. Last but not least, I have used many images from various sites that I have already credited in my PPT, but I am very thankful to Wikipedia, Pixabay, PPNG and a very nice site for physics, that is physicsclassroom.com. Thank you so much. Thanks all. Be safe and take care. Bye. See you in next session.